Hey, what's up guys? So today we're going to look at base SI units. SI stands for System International, and it's the standard units that we use across the world as physicists. The first one that we need to know about is mass, and that mass is measured in kilograms. These used to be defined based upon 1 litre of ice melting into water, and that mass would be a kilogram. It then got replaced by standard kilograms, which were kept in vacuum chambers and kept in laboratories. These mysteriously started to lose mass. So now we actually use a definition of a kilogram based upon Planck's constant, which is a fundamental constant of nature which is unchanging. The second SI unit is that of length, and we measure length in meters. These used to be defined as 1/10,000,000th of the distance from the equator to the North Pole, but it's now defined using the speed of light as 3 × 10⁸ meters per second. The third unit is that of time. So we measure time in seconds. Historically, time has been measured using astronomical measurements. The Earth takes a year to orbit the Sun. A day is defined as 24 hours, which is the time it takes for the Earth to spin around once upon its axis. Though those 24 hours are split into 60 minutes, and those were divided into 60 seconds. But the day can actually change ever so slightly. Therefore, scientists use the frequency of transition of cesium-133. 9 billion of these transitions is equal to 1 second. This is fundamental and it's fixed, and wherever you are in the universe, that will be the same. So it's a really good standard unit. The next quantity is that of electrical current, and we measure current using amps. Historically, this was defined as the current required to electrically plate 1.118 milligrams of silver from silver nitrate. But nowadays we use the fact that the elementary charge of an electron is minus 1.6 times 10 to the minus 19 coulombs. If we take 1 coulomb and divide it by 1.6 times 10 to the minus 19, we get a really large number of electrons, and that number of electrons is defined as an amp. Temperature is really important, and in everyday life we use Celsius or we use Fahrenheit, but physicists always use the absolute temperature scale. If we take Celsius, for example, that's based upon the physical properties of water, where it boils at 100 and it freezes at 0. But this can actually vary based upon pressure. The absolute temperature scale, the Kelvin scale, is based upon the fact that all substances at 0 Kelvin have minimal internal energy. And this is all substances, so it's the same for everything, wherever you are. The next quantity is that of amount of substance. And this is used in chemistry very often. When we're dealing with chemicals, we often measure them in terms of moles. And a mole is defined using Avogadro's number, which is 6.02 times 10 to the 23 particles. This is the same, so a mole of carbon is the same number of particles as a mole of water, 6.02 times 10 to the 23. The last quantity is luminous intensity, and this is measured in candela. And candela was actually defined using the standard candle and measuring the brightness at a certain distance. Nowadays we use very specific sources of light at very specific frequencies. So there we have it, the 7 base SI units. Mass is measured in kilograms, length in meters, time in seconds, current in amps, temperature is measured in Kelvin, amount of substance in moles, and luminous intensity in candela. Thanks for listening. See you all soon.